I believe in flood in days of Noah. And right now I want to do a presentation on local geology, what happened here during this grand event. So if you guys live locally, maybe you guys heard of Mount Tam. I would like to do this presentation in 3 steps. So first, what I would like to do is explain local features. So if you live locally and you see this feature, you will be familiar with them, and it's going to be easier for you to follow along with local geology. Secondly, I want to go over Noah's flood, what happened day 1, what happened first, second, and so on. And at last, the third step would be to bring a secular interpretation of geological event in Massachusetts and the flood interpretation or catastrophic interpretation, and compare them to and see which one will fit better what we see in the field. Okay, let's start. So right here you see Mount Tam. How does that fit into Noah's flood? Mount Tam is made out of basaltic rock, and if you know anything about geology, ocean floor is made of basalt. It's a heavier rock. It's kind of sink down into the asthenosphere, but continental crust is made out of granitic rock. It's made out of like granite, so it's lighter or more of a felsic material. The ocean crust is made out of mafic material or basalt. The Mount Tam is made out of basalt, so you would ask, why is it a mountain top is made out of the same material as the ocean floor? But that's not all. Mount Tam in Springfield or Holyoke or wherever you are, you can see a really wonderful view. Me and my family would really like to travel and look down those cliffs. But how did those cliffs form? Especially during Noah's flood. We're gonna get to that. Actually, if you zoom out on our area, and if you look right here, Mount Tam would be right here, for example. But then you see this hockey shape right here. This would be Seven Sister Mountain. And then you would see this hockey stick going down through Connecticut. It goes to like Mount Talcott all the way to Sleeping Giant. So, and this is the whole entire thing is made of basalt. But not only that, we have different feature here. If you go to like Berkshire Mountain, for example, in Russell, or you go to a Beckett or any other mountain, you see the mountains are metamorphic. So metamorphic rock is rock that had been compressed and heated, and some of these rocks were heated up to like 700 degrees, so it was a lot hotter than the oven, and the whole entire mountain made out of metamorphic rock. So you would think, how does this hot, how was during Noah's flood this mountain was really hot to 700 degrees? Why is it metamorphic? In this we're going to explain all that, but let's just stay tuned. How did it happen? If you guys look at the Massachusetts geology, and you will see that there's a lot of different bedrocks, a lot of different faults. There's thrust faults, there's normal faults, there's many different land masses, bedrocks. It's a really confusing thing. If you, for example, look at North and South Dakota, it looks like they have a bedrock, a fault right there. Well, it's not in their state, so it's really simple. But if you look, we're gonna try to figure out what's going on here and how did it happen during Noah's flood. Okay, let's keep going. We're gonna start our presentation. Connecticut River Valley during flood in days of Noah. All right, so this would be the second part, starting right here. If you guys see those mountains before, you can relate to them, but let's start. All right, let's go back to the map. As we're located right now next to Springfield, Massachusetts, Westfield. Springfield is the biggest city around here, so we're gonna go with the Hartford Basin right here. We live in a rift valley, and if you guys look right here, you have a line going through it, so it goes probably past Springfield, somewhere into Wilbraham, and on the other side there, it's probably in Russell, right where the Russell starts. And in between these two lines, this is the Connecticut River Valley. That's what we're going to be focusing on. It goes all the way up to Greenfield. The eastern border fault, this is an eastern border fault. It goes to New Hampshire and all the way to the ocean. So it's a pretty big fault. Fault is a breakage in the earth. So this whole entire area, that's what we've been talking about. But before we start talking about the Rift Valley, and here's what Rift Valley is. This is a really oversimplified diagram of a rift valley. So On the bottom we have a cenosphere. It's like semi-solid material, almost like, let's think of Play-Doh. You can actually compress it, but it's not liquid. So this would be semi-solid material. On top we have a lithosphere, a continental lithosphere. This would be rock part of the Earth. So if you see the arrow right here, you pull this end here and pull this one here, you're gonna rip the lithosphere. As you rip, you're gonna create a fault right here. On our case, this would be eastern border fault. This is where the Earth ripped. And whatever, as you pull this apart, you would create a big hole right here. Basically, I'm gonna call it a big hole, right? So how did our Connecticut Rift Valley formed? All right, so this is the Rift Valley, basically a lower spot when two continent plates pull apart. I'm gonna get back to the Rift Valley, but let's continue right now. How did Noah's flood started? Bible says, in 600 year, in a second month, in 17 day, Noah entered the ark, and then all fountains of deep broke open. So we know fountains of deep would be ocean, and it would start with fountains deep. We believe the tectonic plate would start to break apart. Whatever caused it, I don't know. However, if there would be any misplacement of rock in the ocean, the first thing that would happen, it would send a massive tsunami wave. And Bible says it, all fountains deep broke open, that would pretty much go around the whole entire world. It would cause massive tsunami. They would probably cover the whole entire world. But here in Massachusetts, we are located, it would bring bunch of sediments from ocean and cover this land with sediments from the ocean, layers of sediments. And then we have a mountain building event. Certain landmass, probably continent of Africa, would collide with Northern America, which would create Appalachian Mountain, and Berkshire Mountains are part of those mountains. I'm not going to go through the entire world right now. I just want to focus on Berkshire Mountains. So when continents collided, it created a bunch of thrust fault and pushed the mountain up. But as you push the mountains up, like you will see right here, one land would connect with the other land. It would push up the mountains. But also when you push the mountain up, the base of the mountain, you're pushing it down into lithosphere. So the more you put on top, it's actually compressing it down into the earth. So some of the rocks, some of those freshly deposited layers from tsunamis was pressed really deep into the ground, and some of them were pushed really high. And of course, they were continental. There was a whole bunch of mass from continents and everything. They caused this mountain erogeny. Let's see, Berkshire Mountains. So first thing, we have a mountain building event. But as tectonic plates continued to rift, Africa would split away from North America and it would rift away. But while Africa was rifting away or breaking apart, this is what happened. This would be one fault appear here, the other fault would appear here. And if you look down here, this would be Connecticut River Basin, Connecticut River Valley. Atlantic Ocean would open right here, past Boston. But at the beginning, we had two faults. And one of the faults is a failed rift valley. So as the ocean opened over here, this rift valley stopped. So basically what happened, as Africa was rifting away, it's ripped a big hole in the ground where we are right now. A rift valley. So, but during the flood, if you rip a big hole and tsunamis going around, we read in the Bible there was a 40 days of rain. It was probably really heavy rain. It would actually start to fill up the hole with sediments, right away. And since we had the new mountains like Berkshire Mountains and other mountains on the other side, which had a lot of wet sediments on them, and all the rain and tsunami wave would actually really rapidly erode all this loose material into the valley, filling it full. So what happened first? If we look at this diagram right here, this is like a oversimplified diagram, but you will see all these. So this is the rift valley, basically the hole in the ground, and you have the mountain here and here. Stuff coming from the mountain filling the valley floor. So the first thing that filled the valley floor is the New Haven air caustic. New Haven air caustic It's 1,500 meters thick, so it's a kilometer and a half. It's a really thick rock. And if we look closer, it's consists of siltstone, sandstone, ercos, and conglomerate rock. From the rock, we see that this is a fast flowing water, high energy. So the water is really fast, because if you see, you can see little boulders in there, conglomerate rock. Like on this rock outcrop, you will see boulders right here, right here. So whatever brought these sediments, it was really fast, and it was really high energy flow that bring this. And I believe 1,500 meter was brought in here in days, maybe weeks, that covered this whole entire. According by the water flow and energy of the water flow, it would be really rapid. But after that, it would fill the valley floor to the water level, and then it would level off on top. The water would actually start to flow more slower, and we would have finer sediments to sit on top. And that's called Shadow Middle Formation. It's 100 meters thick, so it's not that thick. And it's 25% shale, siltstone 26%, sandstone 35%, limestone. There's a little limestone in there. So that's what covered this first layer that I mentioned right here. That's what covered this New Haven Ercos Shadow Middle Formation. But then something really interesting happened. As we have the lithosphere on top, as I mentioned before, and a asthenosphere below that is semi-solid, the reason why the asthenosphere is semi-solid, because it's under a high pressure from continental lithosphere, so it's really, really squished. If you actually remove the pressure from a asthenosphere, it's going to turn to liquid. So it's going to go to a process called decompression melting. So as we create a rift valley, if you remove the material from the top, that would decrease the pressure on the asthenosphere. It would go to decompression melting. Now you have a molten bulge underneath Connecticut River Valley. So as that happened, when it broke through, the basalt started flowing. So this liquid stuff from underneath was going through fissure all the way up and filling the valley floor. And it covered a huge area. If you go to New Haven, Connecticut, all the way to the ocean, all the way to Greenfield, Connecticut, it filled the whole entire floor, maybe from 400 to 600 feet deep of this 150 meter of basalt. So it's pure basalt. It flowed really rapidly. It filled vast amount of area, covering everything of lava. Okay, let's keep going. So here you see we have a New Haven Ercos so far. And as these sediments are filling in, the water keep rising. Bible says the water keep prevailing. So water would prevail. Now basalt flow, it flowed in air, so there was not underwater. Because if basalt will flow underwater, it will be a pillow basalt. If it's flow in air, it would be a column basalt, like we see on mountains, those columns. So after basalt flow, the water continued to rise, and now the basalt was submerged. After it flow solidified, it's submerged. The water probably helped to cool it off even more. But we have more sediments coming into the valley. It's called East Berlin Formation. So now this basalt layers start to be covered with East Berlin Formation. East Berlin Formation consists of many layers. It's almost like a book. You can read it. Like, see right here, I'm looking at the East Berlin Formation, or right there, I'm looking at East Berlin Formation. All these layers, you can actually open them up, and you see fossils in there, and you see water ripples, raindrops, you see mud surface, you see anything. It's almost like a book, what happened. And what's interesting, you can see a surface of mud right here, like you can see it was a surface of water. And then if you dig right here, you see another surface of water. So as this was forming, a lot of time the valley would be full, and then there would be another layer, so water kept rising and kept depositing all these layers as water keep prevailing. But it was interesting, it's only 200 meters thick, and it consists of shale, siltstone, sandstone, and ercos. 7% conglomerate. So there was conglomerate. There's a lot of these rock layers. Says alluvial index 50%, and a lot of them are 100%. So in East Berlin Formation, we have preservation of things like water ripples, we have a dinosaur footprints, we have raindrops. So we have really detailed preservation of different footprints on different features. For example, let me give you a forecast. We're gonna have a break for forecast from Noah's flood. 40 days of rain, flood warning is in effect until rainbow comes up. And that was the forecast. Okay, let's go back. We're gonna continue looking at some of these footprints left in these rocks. So right here you will see a tail impression of the dinosaur, and if you see there's a tail drag. Some people told me these lines right here are tail feathers on the tail. I don't know if that's accurate, if they're just lines. I don't know what those are left from. I'm not a paleontologist, so I'll have to leave somebody else. But if you look at these footprints, you can see a skin impression. Like, let me zoom in. If you zoom in, you'll see a skin impression of the dinosaur. It's another interesting point how these footprints were preserved. Scientists would tell you that dinosaur was stepped after a rain in a mud, and then this mud would dry for like 6 months. There would be no other rain and nothing, and then it would cover them with sediments after 5 months. I don't believe you can preserve a dry mud with preserving a little detail. This is zoomed in. A little details, a skin impression of a dinosaur for 6 months. I don't think it would happen. It would be just blown away by wind. I believe as dinosaur stepped and keep walking, the mud would close his, fill his step right away. So as he's going around, his footprints are filled that same moment with mud, and new layers are coming on top and preserving the footprints. All right. Another interesting thing, if you look after East Berlin Formation, we have a new layer forming. It's Portland Formation. It's probably the last formation that we're going to be looking at. So right here you have a Portland Formation. It's 1,000 meters thick, so it's a really thick layer. On the bottom of this formation, we still see dinosaur footprints. What is interesting, if you go to Connecticut, you will see footprints in an earlier layer, East Berlin Formation. If you come to Massachusetts, it's going to be on Portland Formation. So that would indicate the dinosaur was up walking north, because they would be lower there and higher here. It's an interesting point. I'm still studying that one. But this formation, as water keep prevailing with Portland Formation, probably at the beginning of this formation, dinosaurs were wiped away and carried somewhere else. Some scientists trying to figure out why we have so many footprints of dinosaurs, but we don't have any dinosaur skeleton over here. I think I know why. Because dinosaurs didn't like it in Massachusetts, they moved to Texas. It's a joke. Didn't get it. But anyway, we see only footprints of dinosaurs. And after dinosaurs were gone, the water keep prevailing, and the East Portland Formation keep forming all the way up top, meters, many meters thick, 1,000 meters thick. And now something unique is happening. If you go to this diagram, remember these mountains up top? They form in the beginning of the flood. As the tsunami would go around and rain, these mountains would be continuously eroded. Later on, the Bible says that God put the wind God sent the wind to stop the water. I believe the water was moving, so I believe these mountains were eroded completely. Another thing is, see all these layers? As eastern border fault continued to rift away, all these rock layers started to tilt like this. See, like this. So if you see the eastern border fault continue to go this way, so you would have the East Berlin, you have an Erkas, Shadow Meadow Formation, this would be the basalt layer, and this would be Portland Formation. So all these formations are tilted now, just because the eastern border fault continue moving away, and if you pull the thing underneath, everything just tilted. So imagine movie 2012, you would see the whole entire area extending in Massachusetts during Noah's flood, and the whole entire area is like, whoop, tilted. That would be pretty scary. But remember the mountains before, they formed before? During the flood, there was so much water, and some of these mountains were made out of soft sediments. It keep eroding them. So by the 5th month of the flood, it would erode more and more. So finally, by the 5th month of the flood, it would penoplane the mountains and fill the valley. So Connecticut River Valley would be filled completely, and Berkshire Mountain would be eroded completely. It would create a level surface, and it would probably be somewhere at the ocean level. So if you guys think, how did flood water cover the whole entire mountains? In our area, there were no mountains. It was a flat area where water covered everything. It completely eroded, flat surface. It penoplaned it. So if you would see, the mountain was completely gone. And you have a flat surface, it's probably at sea level. And now water covered everything. By the fifth month, I believe the whole entire earth was covered with water, and obviously our area was underwater. There were mountains elsewhere that were covered with water, but in our area, I believe it was pretty flat during the final peak of the flood. After this event, the water started receding. And remember, when water was bringing all these sediments, it would deposit them in a sheet deposition. It was almost like you would see the valley floor would just cover with sheets of these mud layers, sheets on them. Like the water would go through the whole entire valley with really high speed and cover it. But now, what happened as all the mountains got eroded, and in this process called isostasy, the asthenosphere beneath, when you put pressure on it, it compresses. But when you eroded the mountains, you release the pressure. Now asthenosphere it's not gonna be aesthetically equal, so it's gonna start rising. So when God said after 150 days, the water start receding, as soon as the water start receding and start to erode the mount, like additional stuff from here, and this whole entire area start to uplift. So imagine this would be flat, and now it starts to uplift maybe 1,000 feet up. And as water rushing off the continent, remember these layers, they were tilted? Now it has a sheet erosion. As water running through this valley, it erodes all of these layers. However, as they are tilted, erodes them straight. So now we have these tilted layers sticking out of the ground like this. And if this right here would be Mount Tam. So the reason why we have Mount Tam and the whole entire ridge, because basalt was already solidified. It was hard rock. So when the water was rushing off the continent, it couldn't erode Mount Tam. But Mount Tam was covered with all sediments, and sediments were loose sand, which it was easily eroded. So imagine during the flood, as water rushing off, eroding all the sediments, and Mount Tam remains. So the sediments are gone, and now we have Mount Tam. But also the Berkshire Mountain, as there was a regional uplift, the whole entire area uplifted, it would pretty much happen the same with Berkshire Mountain. Everything that was loose on Berkshire Mountain eroded. And now, why the Berkshire Mountain is metamorphic? Just because the original mountain that was built up there, it was eroded. And now the bottom, the stuff that was pushed down into the ground, that stuff uplifted. So it's actually a base of the mountain that uplifted and got eroded away. And now we have Berkshire Mountain. Okay. And this is a little diagram of what happened here. So you have Berkshire Mountain right here, Pelham Hills right here, and this would be the valley. So this is the hockey stick that I'm talking in the beginning, and this is actually cross section, so you can see the layers are tilted and they're sticking out of the ground. Water eroded everything else because there was sand and clay and mud and everything else, but it left behind the basaltic mount sticking up. So if you stay on the Mount Tam and you look down the cliff, you're actually standing on a rock layer that's poking out of the ground, like at the angle. All right, so this is the basalt sticking out of the ground here, creating a mountain ridge. These mountains, these are the base of the mountain that popped, that arose after the flood and were eroded around. Okay, and now we have an ice age. So during the flood, since there were a lot of ocean floor spreading, which would warm up the ocean because the water would come in contact with the hot mantle below, water would be warm. Also, during the flood, as we see right here, a lot of lava flow, there would be a lot of volcanoes that would block the sunlight, and if you block the sunlight, it would create a really cold environment. Ocean would evaporate rapidly because they were warm. Because they were cold, there would be probably a lot of hurricanes. They would bring the water elsewhere and dump it as a snow. because it's really cold, it would snow. So that caused the ice age. So after the flood, it caused an ice age, and here here in our area, Mount Tan was an island during the ice age. There was glacier everywhere, pretty much. There was a lot of terminal moraines and other things left by glacier here. And as the glacier will start to melt, it blocked a dam. If you look right here, and somewhere in Rocky Hill, Connecticut, it closed the Connecticut River, and it built a huge lake over here that's called Lake Hitchcock. Mount Tan would be an island. Okay, so that's it. That's a short version of the flood in days of Noah. That's how it happened. All the way from beginning, from mountain building event to ripping the big hole in the ground here, and then filling this hole with sediments, and then after that eroding everything, then uplift, and then eroding everything, and then ice age. So this is the quick story of Noah's flood. Now I would like to go to the third and most interesting part, is comparing the two worldviews. I'm probably the first creation geologist here in Massachusetts. They are looking at these rocks from creationist perspective. There's a lot of secular interpretation of all these events. So let me just take a look at some of them. If you go to a museum, you will see a nice little dioramas and displays of dinosaur running through a jungle. And if you see the Dilophosaurus leaving footprints over there. Is it true that there was a jungle here in Connecticut River Valley? I would say it's not. And if you look right here, this is what we creationists would say, that this was a plain waste mud as far as you can see. So it would be mud as far as you can see. That's what we believe that was here during Noah's flood. There were no trees, there were no animals that would burrow, there is no bioturbation, no vegetation, no nothing, just a wasteland. And what do you think we observe on a field? This or this? Let's continue. We observe this. We observe any of those East Berlin Formation, Portland Formation, any of those rocks that you're going to split open, you will not see any bioturbation, you will not see any vegetation. All you're going to see is a mud surface. You will see ripples. I mean, you will see occasional dinosaur foot tracks and something else, an occasional plant that's laminated between the layers. But you will not see anything else. Most of it is surface of the mud. And you can go for hundreds of miles, since there's a lot of road construction, there's a lot of quarries and everything else. Nowhere we found a single plant growing. Is there a zero bioturbation? That's my argument, that there is no bioturbation. However, there is bioturbation. If you look at this picture right here, and this is coming from Suffolk, Connecticut, to include these layers, I think it's a Portland Formation, you will see there is bioturbation. So a clamp burrowed and left traces of clamp burrowing. From this picture, we see that we can't have bioturbation. For me, it's not a problem, just because I'm not claiming that all the clams died during Noah's flood. This clam just buried during Noah's flood. It was brought in by water, and it was landing in a sand somewhere or mud, and it started to bury down, and that's it. So for me to explain a few fossil of clam is easy, because they lived during Noah's flood. But for a secular geologist, they would have to explain why there is zero evidence of any, like you can go for hundreds of miles, and you can, all the rock that we ever exposed, we have never find any ecosystem. It's all mud. So yes, one clamp will not prove that there was any ecosystem. As I mentioned before, we have zero evidence of any plants growing. And it is possible that there could be a plant that kind of step upright and maybe they find it, but there is no ecosystem, there is zero plants growing. There is 1 out of a million bioturbation, which happened during flood. But anyway, my point still stands. Why there is no bioturbation? Why is there, all we see is a surface of mud for hundreds of miles and dinosaur footprints in the dinosaur miles? So the evidence of lack of any ecosystem. The other is sediment deposition and erosion. If we look at these layers, we can see that they were sheet deposition, so there was a lot of water that deposited the sediments. Also, when they were eroded, we see a sheet erosion. So the water would flow through whole entire valley, eroding all the sediments the same. So it would kind of like lay them down as a sheet, and it would actually erode them as a sheet. So they would show a catastrophe instead of like they would say that it's a flat plains, and there would be a lot more channelized erosion. Also, the rates of erosion. This is I'm still working on it, but rates of erosion are really really slow. If you actually divide, they said it happened 200 million years ago. So if you take 100 feet, 1,000 feet of uplift divided by a million years, it would be like nanometers of erosion per year. And we know the erosion happens a lot faster. So we cannot have millions of years in here just because of erosion. There's and the third point that I would like to bring up is increased rates of basaltic flow. We have a lot of basalt flow. It would be 600 feet thick, covering from ocean, from New Haven, Connecticut to Greenfield, Massachusetts. Huge layer of basalt. And there's two ways to increase basalt flow. I mean, there's other ways which is not going to fit here, but if there's a mantle plume, the basalt would come from deep inside the ground. We can have fast basalt flow, but there is no mantle plume here. And the other one is decompression melting, as I mentioned before. But in order to decompress for this much basalt flow from decompression melting, you would need a fast rate of increased expansion rate. Faster movement of tectonic plates pulling apart would create more fracture, allowing more magma to flow. So this would be consistent with CPT model. It ripped the earth really fast and basalt just came up. Instead of doing it by conventional science, would say it's going with the rate of fingernail growth of 1 centimeter a year. So if the continents would split 1 centimeter a year, you would not have this much basalt without mantle plume. So rates of basalt. Okay, so this presentation is almost coming to an end. I really want to continue my education in geology. This is really fascinating how we can see the flood. If you guys have any question, you can comment below. Here's some dioramas that I went through, and welcome to Bible Adventureland to hear more. Also, we're gonna have a conference soon. This is the practice for the conference. Thank you so much, and I'll see you soon.